Hello everyone, my name is Ashish and welcome to the Academic channel. So today we are going to discuss the interview questions for Java full stack developer profile for HCL Technologies. And the technical stacks are like core Java, REST API, Spring Boot, microservice and Angular. So like basically one of my friend has appeared in as in Java full stack developer profile for HCL Technologies, and he has shared me all the interview questions being asked to him in the first round of technical round in HCL Technologies, and he was selected and moved to the second technical round in HCL Technologies. So he has shared me all the interview questions of the first round, and maybe in the second week he is going to give the second round of technical round. And yeah, and like he will share me those questions also, and I will try to bring out with you or the questions being asked to him in the second round also. So now let's discuss the interview questions he has been asked in the first round. So the first question he was asked, like, do you have the idea on the difference between the Spring and the Spring Boot? So like basically here the interviewer wants to understand that like, do you have the knowledge on the Spring side and also the Spring Boot side, right? So how you can give the answer? So basically you can say that Spring is used for building the application. It is used to build the web application, but in Spring it uses Java, the EE framework. But Spring Boot uses to develop the REST API. So mostly we use the Spring Boot to develop a REST API. So the second point you can say that the primary feature of a Spring is a dependency injection. So what is dependency injection? So basically a dependency injection by which we can bring a loosely couple to our like program or our application. So in this the web application is like initiate the bean, it creates the instance of the bean, and as a developer we does not create the instance of a bean, we just use it, right? So this is a dependency injection. So in Spring Boot the primary feature is like auto configuration. So what is auto configuration? It is basically is yeah, so like basically the Spring Boot automatically configure the classes based on the requirement. Only we need to declare all the classes inside our pom.xml as a starter, right? So the next point you can say that Spring requires more like configuration and the Spring Boot requires less configuration. And and guys, I hope if you have worked in a Spring that you know that we need to require or to do the more configuration to do the setup of a Spring application, right? So there we need to add the jars, download the jars and add all the jars to the class path. And also we need to deploy that particular application in a server, and then we try to test it, right? But in Spring Boot, it is not the case. It has already embedded like database also, that is like Tomcat, and also it has a JT server, right? So it has already like a servers, so only we need to so basically it requires a less configuration. So the next point you can discuss that Spring we need to write a more boiler code. So what is boiler code is the same code we are writing again and again in the different classes, so that is the boiler code. But in Spring Boot it reduces the boiler code. The next point you can say that in Spring, the developer manually defines the dependencies in a pom.xml. That in pom.xml, the every dependencies had to be added manually by the developer. But in Spring Boot, like it is not the case. So it has already a starter. Only we need to put the starter, and all those dependencies will be auto configure and download by the Spring Boot, right? So this is the some points different between the Spring and a Spring Boot. So the next question he got that which annotation you have used in your Spring Boot application to build a REST API. So basically you can like answer to the any annotations which you have used. But here I have defined or discussed some of the annotations which are common and like mostly used in the REST API. So first annotation is like @ entity. So at the rate entity annotation is a class label annotation which we use with the model class. Let's say that I want to create means I want to map particular model class or the Pojo class to a database table. Then we use at the rate entity class over the model class, right? So the next annotation is right at the rate rest controller. So at the rate rest controller is used to create or to mark your Java class as a controller. So rest controller contains the two annotation. First at the rate controller plus at the rate response body. So if you don't want to use at the rate rest controller, then you can use separately two annotations, at the rate controller and at the rate response body. But with the Java boot version 2, they have clubbed these two annotations into single, that is at the rate rest controller, and this is used to mark your Java class as a controller class. The next annotation I have used at the request mapping. So request mapping is used for mapping your URL. So basically it can be class level or it can be method level. So right, so in the controller class, if you're using at that request mapping at the class level, then it will try to match that URL and then it will try to call this particular controller. And if you're using that request mapping in a method level, then it will match to those URL which is provided in the request mapping annotation, and then it is try to call that particular endpoint inside a controller. So next annotation is at the rate auto wire. So at the rate auto wire is an annotation which is used to define a dependency injection to your project, right? So with this auto wire, the web container is going to create the instance of that particular class, and then we can use the reference variable to call the methods or to call the member variable of that particular class, right? So basically auto wire is used for the DI concept. So next annotation is like at the rate post mapping. So here at the rate post mapping contains the two annotation, at the request mapping plus at the rate post. So at the rate post method is the HTTP method and post method is used to create the resource. But we can club this together and we can directly use at the rate post mapping and then we can provide the URL. And in the same way we have another method like get mapping. So this is for the get method, and in the same way we have the put mapping and also add the red delete mapping. So next is add the red service. So add the red service is used to mark your Java class as in service class, and inside the service class we declare all the business logics. So next is at the red path variable. Path variable is used to capture the values we are passing in the URL. And at the red valid is used for the validation purpose. It is used by the hibernate validation, and yeah, it checks or it validates the client data which we are sending through the client. Okay. So next is request body. So request body annotation is used to capture the object or the resource which we are passing through the client side. So these are the some of the annotations which you can define, like which you have used in your Spring Boot application. So the next question was how you will do the CRUD operations in your Spring Boot. So basically, this is a very interesting question because, and also the important question, it will define that how much knowledge you have regarding the CRUD operations, right? So basically you can define this means answer this in a very stepwise step process. You can start with your application that you have to create a Spring Boot application using a Spring Slicer. Then you can import this to any IDE, let's say to the Eclipse. Okay, and then you have to create a different like packages. So already I have a sample project for the CRUD operations, so I want to show you directly. So this is a Spring Boot CRUD application, and inside the source folder and the Java folder, you need to create all the packages. Let's say a bean package to create a bean class or a model class, a controller package to add a control class. You have to create a repository package and also a service package to add a service class, right? So in the bin, so let's say that I want to add a subset I want to add a subject resource inside my database, and the subject has two like member variable, ID and the name. And ID is like a string and the name is also a string. So you have to define that. First of all, I will create a model class, and I will annotate that model class with the added entity. And here I am using a JPU repository, right? So JPU repository is basically using the Hibernate underneath. So this model class subject, I will annotate with other entity. So these entity will map my like model class with the table inside my database. And let's say that if I'm not using at the table annotation, then it will directly create the table inside the database with the name subject. Or if I want to change the name of the table, then you can define the name inside this at the table. Let's say that if I define here subject one, so it will create the table with the name subject one inside your database. And at the rate ID you can use for the primary key. And also we have created a getter and the setter method. So this is regarding the model class. Next, I will create a controller class, and the controller class will contain the four endpoint. First endpoint to fetch all the data from the database. Second endpoint for creating a new resource in the database, for creating a new subject in the database. And the third one to do means to update any subject to the database. And the fourth one to delete a particular subject by passing it ID to the database. So I will create one controller class with the name subject controller, let's say, and then mark this class with at the rate rest controller. So rest controller is to will mark your this class as an controller class. And here and then I will create the endpoint. So first, let's say I am creating to fetch all the subject info from the database. Okay, so and I will mark this method as an at the request mapping, and here I will pass the URL. And here you can see that I'm not defining any method, so it means it will take by default a get HTTP method. In a similar way, you will create another endpoints like add subject, in which I am using request mapping and then method as post. And then in the value, I am passing the URL. And here you can see at that request body, it will capture the payload which you are passing from the client side, and it will store, and then it will store in the subject model class, right? In the similar way, you can create other two like endpoints also, like put and delete, right? And the next I will create the service class. So service class you have to create and mark this with the added service. And then inside this you have to write your business logic. So basically this method to fetch all the data, subject data from the database. So in this I have written the piece of code to fetch the data, and here I am using the repository. So I have auto wired this repository, and this subject repository is an interface, right? So I will create an repository interface inside my repository package, and I will extend this with a CRUD repository. Either you can extend this with a JP repository also, but here I have made with the CRUD repository. So what is the difference between, yeah, so also you may get the question, what is the difference between the CRUD repository and the JP repository? So with the CRUD repository, you can only do the CRUD operations like fetch, save, delete, put. Okay, but with the JP repository, if you're extending with the JP repository, then you can do the sorting and the pagination also. So pagination and the sorting are also like supported by the JP repository, but with the CRUD, only you can do the CRUD operations, right? So let's move to the service layer. So here I will annotate with the repository, and then I will call this find all method. So basically find all method is coming from the CRUD repository. So find all method is predefined method inside the CRUD repository. It is used to fetch all the info from the database. And also in the similar manner, we have the save method, and just in the save method, you have to pass the reference or the object of the subject, right? And in the similar manner, you if you want to update, then you can use the same save method. So if this like object is already present in database, then it will not create it, it will update it. If this object is not in the database, then it will update this subject in the database, right? For the delete, you can use the delete by id, and here you need to pass the id for which particular id you want to delete the subject, right? So this way you can means explain him all the process or all the layers one by one, and how you have to configure and you have to do the CRUD operations. And also in the last you can say that inside your application.properties file you have to define which database configuration you are using. So for here I'm using MySQL, so you have to define that all MySQL configuration you have to define inside application.properties file, like driver name, URL, username, password, dialect and all, right? And the port, server.port, it means that I will start this application in the 9111 port number, right? So by this way you have to define or tell the recruiter all this step one by one, and he will be like very impressed by you that you basically you know all the process and the annotations, and you have really worked on the project, right? So this way you can define if you have if you've been asked the question like how you will do the CRUD operations, right? So next question, he was asked that how to use the custom query for fetching the data from the database. So in this you can use the JQL also. So custom queries are the queries you can write in your repository class. So for that you have to use at the rate query annotation, and inside means with the at the rate query annotation you have to write your SQL query. Let's say that you want to fetch the data. Let's say select star from the table name where the ID equals to this or anything, right? So you can simply write the SQL queries in your repository like method also. So for that you have to use at the rate query annotation. So with that you can do, right? Yeah. So the next was like, what is actuator? So basically, actuator is like one of the component of a Spring Boot, which help us to monitor or yeah, which help us to monitor your application into different environment. So basically, with the actuator, you can monitor or you can check the status of your application, that whether your application is live or it is dead. Okay. So like it is one of the popular feature of a Spring Boot, and it provides basically the endpoints. By accessing that endpoint you can check the status. So endpoints are like slash health, slash thread, slash thread pool, slash thread dump, and the others, by which you can check also the thread bean, by which you will get all the bean info. With slash health, it will give you the status whether your application is up or it is down. And in the similar way, with the thread dump, it will means give the info that how many thread dumps are there. With the thread, you it will give the info how many threads you are using in this application. Yeah. So basically actuator are used to monitor your application in a different environments, right? Yeah. So I hope you understand the point. So next question, he was asked that what is thread, and also explain the life cycle of a thread. So basically, a thread is a single execution of a program. So thread is a single sequential flow of a control within a program. So how you can understand this? Let's say you have created one like hello class, and inside the hello class you have created one main method, and inside the main method you are creating the object of this particular class, and then you are accessing that particular method of that class, right? So when the JVM run, yeah. So when you run this program, so JVM checks that it has a main method. So what the JVM will do, it will create a main group with the name main, and then it will create one thread with the name main. So with that thread will try to execute your main method, and then it will execute your code line by line. Okay, and then it will see that you have created the object, and then with that object you are calling one particular method. Yeah, so all these execution will be done through a particular single thread that is named as a main thread, right? Because you are so this code is inside a main method, so JVM will create a main thread. So this is so this execution is done by a single thread, that is a main thread. So this type of single execution flow of a control within a program is known as a thread, right? So thread is basically used to run your program and to do the execution which are written in your like a program. So thread so like a thread can be single threaded also, it can be multi-threaded also. So in multi-threaded, like multiple threads will try to execute your program. So we implement a multi-threaded environment when we want to execute the program, and we need the result in a very faster manner. Okay, then we can use a multi-threaded environment also. So the next was question was to explain the life cycle of a thread. Basically, the life cycle of a thread means it has a different stages. First, it has a new stage. Second, like ready to run, then the running stage, then the timed waiting or the waiting stage, or sleep stage, or the blocked stage, or the terminated stage, right? So when a new thread is created, okay, let's say that I have created a new thread with the thread equals to new thread, then it will be in a new stage. And when I call a start method thread.start, then it will go to a runnable state, means it will go to a ready to run state. But if we start a thread, then it is not that it will call a run method, means it will be not be in a running state, it will be in a ready to run state only. So ready to run state, after ready to run state, it will move to running state only when the CPU will allow that particular thread to go to the running state. If we will start the thread by calling a start method, then it will not going to run, means not going to execute a run method. Probably it will be in a ready to run state, and the CPU will decide when that particular thread to be moved to the running state. It means that when that particular thread will be called the run method, and inside the run method, the task or the task is written or the logic is written which we want to thread to work, right? So let's say that a CPU has allowed that thread to go to, means to run uh, that thread, then it will go to a running state. And after running state, let's say that someone has called a sleep method to that thread, then it will go to a timed waiting stage, or let's say called a wait stage or a join state, or a park nanos method, or a park you until, then it will be in a timed waiting stage. So it will wait for a particular time, and when the times will over, then again it will go to a like runnable state, means like ready to run state, and again it will wait for the CPU to get it time. So again, the CPU will decide when that particular thread will run, right? So in the same manner, it has a wait method. If someone calls a wait method, then it will go to the waiting state. In the same manner, join is there, park is there, right? So if any thread is waiting, let's say that someone call the wait method, then that wait can then thread can will go to a waiting state, and that thread can be awake if someone calls notify or notify all. So what is notify method? Notify method is used to awake up thread which is in a waiting state, and notify all. So the difference is that if we want to awake a particular thread from a waiting state, then we can call notify. Let's say that there is n number of thread which is in a waiting state, so then we need to call a notify all. So notify all will awake all the threads which are in a waiting state. So now the question is how it will decide that which thread it should awake first. So the most waiting thread will awake first. Let's say that some thread is waiting from 5 minutes, some is waiting from 7 minutes. Then the most highest means highest or the longest waiting thread will be awake first by the notify all method, right? So 7 minute waiting thread will awake first, then the 5 minute like thread will awake, right? I hope you understand the point. So yeah, so in the same way, another stage is like sleep state. If someone calls a sleep method, then it will go to a sleep stage, and then the notify and the notify all method will not awake the thread which is in a sleep state, right? So it will awake whenever the particular time will get over, right? In the same manner, it is a block state. If someone put a lock, then it will go to the blocked stage, and it will be in a block state until unless the like like a lock is there for that particular thread. And if let's say a thread has means ran its run method, and it has completed its job, then it will exit, and then it will go to a terminated state. So these are the stages in which the thread goes in its life cycle. I hope you understand with this like program, means with this diagram. So next question he was asked Yeah. So what is lock in Java? Yeah. So what is lock in Java and how it's different from a synchronized block? So basically, lock is an interface available in java.util.concurrent lock package, and the Java lock like act as an like a thread synchronization mechanism that are similar to the synchronized block. So basically, lock interface work and the synchronized block work is same to provide a lock to that particular implementation or object, right? But like there isn't some difference between the synchronized block and the lock. So the first difference is that with the synchronized block, it does not provide any guarantee of sequence in which the waiting thread will be accessed. It means that we can get a irregular result if we are using a synchronized block. But it means that the sequence will not be guaranteed that which waiting thread will be accessed. But with the lock interface handles it means that we can achieve result in a sequence order because the sequence guarantee will be done by the lock interface. The second difference is that with the synchronous block, it does not have any option of time when the lock is not granted. But with the lock interface provides such an option at the time of granting the lock, right? So the third point is that synchronized block, it can be contained within a single method. But the lock has a different methods like lock, unlock method, which can be called into different method. So these are the some points like difference between the synchronized block and the lock interface in Java. So this is very important question and it is coming from the content like package. And nowadays means I have observed that like if the recruiter is going to ask in a like a multi-threaded topic, then they are like mostly focused on the concurrent topics, right? So you have to like very well prepared with the concurrent package interview questions. So yeah, so like if you are like interested to me to so yeah so like so that I will create the more interview questions on the concurrent package, then you can you can leave a comment or you can like write a comment that you are interested for the interview questions on the concurrent package also. So I will try to create all the important interview questions for from the concurrent package of Java, right? So next question, let's discuss the next question which he got. Yeah. So the next question was that he was asked to explain the JVM architecture, and yeah. So I have taken this image from the platform engineering.com website, and here I have seen that this is very like pretty well defined in a very structured way the architecture of the JVM, right? So this is whole is an architecture of the JVM. So the main like components or the systems present is like class loader subsystem. So basically this is like JVM, and the JVM contains the class loader subsystem, and the class loader subsystem contains the loading, linking, and the initialization. And the next block, it contains the memory block. So basically 5 memories are there in the JVM, and the next block contains the execution engine. So basically it execute your program or run your program. So here it has the interpreter, JIT compiler, garbage collector, and all, right? So now we are going to see how these means JVMs work internally when we compile or run our program. So basically, when we write a Java class, let's say, and save it with a .java extension, and with the compiler, we try to compile that class. Then the compiler work to check the syntax error, and also it compiles means it convert that particular .java class to a bytecode. So what is bytecode? So basically, bytecode contains the dot class extension. It contains the hexadecimal values, okay, or the binaries values like 0101. So basically this can be read by the machine only, so it cannot be like read by us. So compiler compiles the code, it checks the syntax, and then it converts that particular dot java class to a bytecode, means a dot class file. Now this dot class file will be means loaded by the JVM. So while loading, there are like three class loaders. First, the bootstrap class loader, extension class loader, and the application class loader, right? So extension class loader is going to check that class is present inside .exe file or not, and the application class loader is going to check particular class is present inside a class path or not. So these are the modules from where the class loader checks the class, like where the class is present, and then it is going to load that class. And the next comes the linking. So basically I will go by like one by one. So first I will explain the loading. So what do you mean by loading here? So loading means reading the class files and storing corresponding binary data in a method here. So while the loading is done, it is going to store that particular info of that class inside the method area. Okay, so method area is like one of the type of a memory inside a JVM. So what type of info the JVM stores inside a method area? It stores the fully qualified name of a loaded class or an interface or an enum. Okay. It also stores the fully qualified name of its immediate parent class. So it stores the fully qualified name of a class. If there is any parent class, then also it store the fully qualified name of a parent class. And then it also store the modifier information. Let's say we are using private, public, or the protected or default, so it is going to store all those info inside a method area. Also the variables or the field informations are stored inside a method area. Then the method informations, that which methods are there inside the class, that all these informations are stored in the method area. And the constant pool informations and so on are stored inside a method area when the class is loaded by the class loader, right? So after loading a dot class file, immediately JVM will create an object of type class to represent a class label binary information on a heap memory. So after loading and after storing all the info to the method area, the JVM will create a class type of object to represent the class label of a binary information on a heap memory. Oh, right? So it will create a class object, right? Now the next thing, now the next thing is like linking. So after loading that class by the class loader, the next step will be linking. So linking contains the three part. First step is like it will verify, then it will prepare, and then it will resolve. So what is done in the verification? So verification is yeah, basically a process by which it ensure that the binary representation of a class is structurally corrected or not. So it's checked that whether that binary that bytecode is checks that dot class file or the bytecode file is like correctly structured or compiled by a valid compiler or not, right? So internally the bytecode like verifier, which is the part of class loader subsystem, is responsible for this activity. So basically there is an bytecode verifier. So bytecode verifier will verify that particular bytecode, whether that bytecode is particularly structured or it is in a proper structure or not, or it is or it is like compiled by a like verified compiler or not, right? So this is the yeah. So let's say that if that particular dot class is fail while checking that file, then it will give one exception, and the exception name is yeah, like java dot lang dot verify error. So this error you will get if in any chance JVMs fail by verifying that particular class. If that particular class is like compiled by not a valid verifier, then it will give this particular error. Okay. So next stage, so after the successful verification, the next stage come the preparation. So basically in this phase, the JVM will allocate memory for the class label static variables. So the memory will be allocated to the static variables and assign default value. So till here, the default value will be assigned to a particular static variables. Okay. So here you have to note that till here the default value will be allocated. So in the next stage, in the initialization stage, the original value will be assigned to the static variable, right? So till here the preparation, it will store the default value for a static variable in the preparation, right? I hope you understand. Now the next stage come the resolve. So here the resolution, so it is a process of like replacing the symbolic reference used by a loaded type when with the original reference. So basically the symbolic reference are resolved into the direct reference by searching through the method area to locate the reference entity, right? So these are the three steps are done inside a linking. Now the next steps come the initialization. So inside the initialization, the original value of that particular static variable will be initialized to that static variable, right? Yeah, so this is the initialization. Now it has like the five memory, and the different like variable or the different object will be stored inside this memory. So first let's say a method area. So inside the method area, as I discussed, as I already like explained, that inside a method area, uh, like particularly for every JVM, the one method area will be created by JVM, right? So inside the method area, the class label like binary information will be included, like the fully qualified name of a class, fully qualified name of an parent class, and also it content it yeah it's also contain the modifier information and all, right? So this is the method area, and the constant pool information is also there inside a method area. Now the next comes the heap area. So inside the heap area, so heap area will be singly created by the JVM for, okay, so method area and the heap area will be common for all the programs in an JVM. So inside the heap area, like object and the corresponding instance variable will be stored in a heap area. All the instance variable of a class, all the object will be there in a heap area, and the array will be also stored in a heap area, because array is considered as an object inside Java, so it will be stored in a heap area, right? And also there is stack. So particularly for a single thread, a single stack will be there. So let's say there is three thread in a program, then three stack area will be uh, will be created by an JVM. So stack will contains the information of the next execution of a thread, okay? And also there is PC register. So PC register will be for a particular thread. Let's say that there is three thread, then the three PC register memory will be created by a JVM, and the PC register content the information of the method execution information, right? And also it is a native method stack. So native method stack will be for the particular thread also, and it will contains the third party, it will contain the third party language like programs information will be there in a native method stack area. So these are the five areas. And the next like sub part is like execution engine. So basically it is an interpreter, git compiler. So interpreter are in which it reads every code line by line, and it checks and then it gives the error when it means it has error. But JIT compiler is more advanced version of interpreter, because it checks your read line in a one go, and then it provide the error if it has, right? So next is like garbage collector. Garbage collector is used to delete the unreferenced object present in an JVM, right? And the native method interface is used to give the support for the third party language classes, right? And these JVM run inside an operating system. Operating system can be Windows, Mac, Linux, and Unix. Yeah. So this is the brief description of your architecture, right? So this is very a lengthy topic, and yeah, so like I can speak on this topic like I can speak to this topic almost like 1.5 an hour, but here we have a very short time to discuss. So guys, if you want me to create a separate lecture for JVM architecture, where I will explain every process step by step and in a very deep manner, then you can give a comment that you want to create me a separate lecture on the architecture. So I will create for you a separate lecture of like 1 hour, in which it will be a very deep manner. I will explain all the flows and also the working of every component inside an JVM architecture, right? So in a brief manner, you can explain this, and guys. Like, believe me, if you are able to explain this in a very deep manner, then the recruiter will be very impressed to you, because you will, means like, he will come to know that you have a very deep knowledge inside a JVM architecture. So this is very a good sign, right? So this is all about the JVM architecture. So the next question he was asked, like, let's move to next question, is like, what is Spring Security? So basically, the Spring Security is a separate module of a Spring framework. It focuses on providing the security to your web application. So it provide like authentication, authorization in your Java application, and also it take cares the security, like the vulnerabilities such as CSRF attacks. So we can, like, we can safeguard ourselves by using the Spring Security. So what is authentication and the authorization? So authentication is the process by which it checks whether the particular user is a correct user or not. And what is like authorization? Authorization is a process by which it checks, means it allows to access those modules which are assigned to him. Let's say that there can be two users. It can be admin, it can be simple user, or agent. So admin has access to all the modules of your application, but the user can have a particular model access, right? Or a module access, means the admin can write and read, but maybe there is chance that user can only read to the some modules. So these type of like permissions we can provide to particular user by using an authorization, and we can achieve this through the Spring Security. And for that we can use at the rate enable web security annotation, and we have to create a separate like config class and all. Yeah, so for this, guys, if you want another separate lecture, then then you can comment this, that you want the another separate for a Spring Security, then I can create a separate lecture on this. So next was that question was like, what is a Spring Profiler? So basically, the Spring Profiler is an like another component in a Spring Boot, which help to decide that which, let's say that I want to use a different database for a different stages of my like development. Let's say that I have a like dev environment, I have a PP, the pre-prod, and also the production. So in development phase I want to use a MySQL, and in production phase I want to use the PostSQL. So how we can achieve this? We can achieve this by using a qualifier, right? So here the profiler is used to do, means to choose the profile which we can choose in every stage of our like production or our like development. So for that we need to create a separate application, like application.properties file. Let's say that for dev we can create application dash dev.properties. For production we have to create application dash like product, and then dot properties file, and inside those property file you have to define the different database configuration. For dev, if you want to use MySQL, then you have to define MySQL configuration inside a dev properties file. And inside product, if you want to use the PostSQL, then you can define the configuration of PostSQL inside your like the production secret file. Okay, yeah. So this way you can use the profiler. So next, yeah, so these are the questions which were asked to him, and the next question was like, do you have any questions or the query for him? So in this, if you have any doubt regarding the project or regarding anything, then you can ask the recruiter directly about your questions or the queries. Yeah, so these were the questions asked to him in the first round of interview in HCL Technologies for the Java full stack developer, right? And he was like selected, and the next he will go to the second like the second round. And yeah, so he will share me all the questions of the second round, and then I will try to create the lecture on the second like round also. So thank you and have a nice day. See you in the next lecture.